So naming. So when we're naming compounds, so let's start with some simple ones. Naming ionic compounds is perhaps the simplest thing to do. And main group ionic compounds consist of cations and anions, usually one cation, one anion. There's ways you can get, we'll see some examples pretty soon where you could actually have different, more than one. But so if it's, the main group cations are just named after the atom. It's simple enough. So Na plus, sodium missing an electron, is the sodium ion, the sodium cation. Lithium cation, potassium cation, rubidium cation. That's simple enough. Anions get the ide suffix. So ide suffix. So chlorine becomes chloride. Fluorine becomes fluoride. And so if you're talking about a compound that's just one cation, one anion, it's pretty simple. Sodium chloride. Transition metal ions can actually have different charges. You can tear off different numbers of electrons depending on the context. And so you have to have a number there. So, iron oxide, you don't know for sure if it's an oxide of Fe2 plus or Fe3 plus. So you have to put a Roman numeral there. Iron 2 oxide, Fe2O. So what would the correct formula for aluminum oxide be? I'll pause. You can pause for a second while you think about that. Okay, coming back. So if we look at the sum up the charges, then aluminum always has a +3 charge, whereas the oxygen anion oxide has a -2 charge. And in order to have a net neutral ionic compound, you would have to have 2 aluminum and 3 oxygen. So that is actually, so we don't need to say Al2O3 in the name. We don't need to put like a 2 here and a 3 here and a 2 here, because these compounds always have the same charge. So aluminum oxide is enough to uniquely say it's going to be Al2O3. Common name for this compound is alumina. You can have common names as well as well-defined chemical names. There's actually an organization, IUPAC, whose job it is to come up with unique identifiers for chemicals. You might think that's a simple thing, but once you get into some wacky organic compounds that are produced biologically, it actually becomes very complicated to come up with consistent names. Okay, there are ions that are polyatomic. For example, ammonium is NH4 and a central N and 4 H's around it, but it has one less electron than it should. So the ammonium ion, the sulfate ion is more complex. You have a sulfur in the middle and 4 oxygens around. And it turns out, and we'll learn how to figure this out later, it has an extra two electrons. And so it has, that then you'd get just from adding up the electrons of the elements. So that's the sulfate ion. Special class of polyatomic ions, you'll see a lot, acids and bases. H3O+, hydronium, OH- are particularly important ions. And we'll get more into acids and bases later, but those are classes, hydrochloric acid that are important to name as well. Some common polyatomic ions, I won't make you memorize these. I'll give you the chemical formulas that you would need. But it's useful to know of the existence of these polyatomic ions as you get into, if you're reading chemistry textbooks or chemistry research papers or reports from underlings, knowing what actually is being referred to. So you don't have to look it up every time. Interestingly, there are a lot more polyatomic anions than polyatomic cations. There's only, ammonium is probably the most common one. There's a few more, but far less than polyatomic anions. Many compounds do have non-systematic common names that are still used today. Just because you know all the IUPAC names, there's other names that come up a lot. For example, methane, ethane, propane, butane. These are not like the names you'd guess just from looking at the trying to like name the compound in terms of the different atoms that it has, but they're the common names that existed, and so people use them. Ammonia, phosphine, nitric oxide, nitrous oxide don't really follow the naming conventions as well. Water would be a something that definitely does not follow its context. So you should be familiar with these as well. I won't ask you to know these, other than water. You should know what the chemical formula of water is. But generally, I won't quiz you by giving you a problem with stoichiometry that has phosphine in it, and you have to remember it's a pH 3. I'll give you the molecular formula. So that's about all I'm going to do on naming. The more you know, the better, but it's not going to be a big part of what's being tested on this. It'll just help you go through things faster. It is important to use the appropriate name in the appropriate circumstances, so you don't end up like the people here that are not being very careful with chemistry, unlike the bartender. I don't know if you can read it. I'm a chemist, so I'll just have some H2O. I'll have some H2O too. Here we are, gentlemen. Thanks. Yeah, so be careful with what names you use in what context. And that is it for the first segment.